Good morning, everybody. Today we are going to study the example number 13 from the problem set number 4 from the chapter Arithmetic Progression for the class 10. So now, as in earlier video we had seen the example based upon example number 12, and very similar kind of example we are having in front of us, that we have to show that, we have to prove that. See what we have to prove. M times the mth term is equal to the n times the nth term. Then we have to show that m plus nth term of the arithmetic progression is 0, provided this m is not equal with n. M and n are very different from each other. Now, similar to the example number 12, we have given a condition is that, what is the condition? M times, I will mention over here, m times means m multiplied by the mth term, that is tm. This is exactly equal with n times multiplied by the nth term, that is tn. This is given to us. This is what we have given. Under this situation we have to show that m plus nth term is 0. So see how to prove this thing. So as we all are know that nth term of arithmetic progression is given by, we know that what we know that the nth term is given by tn is equal to a plus n minus 1 into d. This is the formula for finding the nth term of an arithmetic progression. Similarly, if I replace this n by m, we will get the formula for tm, that is the mth term, which is a plus n minus 1. Sorry, we have to replace n by m, so m minus 1 into d. So these are the two formulas that we are looking for. And now we will go for the given condition. What we have given condition is that, but we have given that m times m multiplied by tm, this is equal to n multiplied by tn. These two terms are equal. Now we have to replace the values of tm and tn in this equation. We will get m multiplied by tm, mth term is given by a plus m minus 1 into d. This is the mth term. This is exactly equal with n multiplied by the nth term, which is given by a plus n minus 1 into d. That these values are replaced by us by using these two equations, tm and tn. Now, very similar to the example number 12, we have to proceed further now. That means we have to multiply by this m to the inside, whereas also by the n to the inside of the bracket. So this multiplication will gives us m into a, that is am, plus m multiplied by m minus 1 into d. Very similar to the other side, if n multiplies inside, we will get an. Similarly, n multiplied by n minus 1 into d. So these are the equation in front of us. Now we have to move this other side of the equation to the opposite direction. That will gives us, what we will gives us, that I will rearrange the terms, that is am. After am, I will have the place for an, but in an opposite sign by transferring to the other side, minus an. Now the remaining terms are plus m into bracket m minus 1 into d, along with we are having the other term from the other side, minus n in a bracket n minus 1 into d. Now these all terms are equal to the 0. Now we are having a pair of terms. This is the first term and this is the second pair of the term that we are going to consider. So from the first pair we can have very easily a to the common. So what happen in a bracket? M minus n. And similar to the last example, we can have d as a common. If you remember, then you can imagine that d is a common. Then in a bracket there is only m in a bracket, m minus n minus n in a bracket, n minus 1 bracket close. So next few steps will be the calculation in this second bracket only. Rest of the things remains as it is. So a in a bracket, m minus n bracket close, plus I will write d and bracket first of all, and now we are having the calculation of inside. So after multiplying by m and after multiplying by the n, we will get m square minus m, and by minus n we will get the multiplication, minus n square minus minus become plus n. So this is the term. So now we will get a in a bracket m minus n plus, again I will write common part first of all, and now we are having the interior replacement. I will rearrange the terms. M square minus n square, square terms we will write sequentially, minus m plus n after that. Now next the remaining terms will be as it is as earlier, a in a bracket m minus n plus, again I will write the common part that we had taken earlier as it is. Now we are having the replacement for m square minus n square by using the formula a square minus b square, that is m plus n. In first bracket will contain the addition, whereas the other bracket will contain the subtraction of both the variables m plus n, m minus n, and from the remaining two we have to take minus common. So after taking minus common we will get m minus n is the second bracket. So now again we are having the similar term as usual, a in a bracket m minus n plus, now if I observe this bracket, we can take from this bracket m minus n and m minus n outside of the bracket. Now we are having d into bracket m minus n, this is equal to 0, and what left in a bracket is only m plus n and minus this total bracket is goes out to the bracket, so there is only 1. So now if I consider this is the first term and this is the total second term, we will imagine that we can have m minus n, this bracket is common to the two terms, so one can has m minus n is completely outside or taken as a common from the two terms. So what left inside, from the first term there is only a plus, and from the second term m plus n minus 1 into d. So we are having this equation. Now we are having in front of us, that is the product of this first term and second term to be 0, and product of two term is possible to be 0 if either one of the term is 0. That means we have, this implies that either a plus m plus n minus 1 into d, this is equal to 0, or we can say, or m minus n, this is equal to 0. But we have given that, but initially we have given an example that m and n are different, means m minus n this should not be equal to 0. The difference must not be equal to 0 if two terms are not equal. So what this implies? This implies that a plus m plus n minus 1 into d, this must be equal to 0. We quote this as equation number first. So by using the given information is that m times the mth term is equal to the n times the nth term. We are at the equation number first. Now we have to see what we have to prove, that we have to find that m plus nth term which is written as tm plus n हे आपल्याला फाइंड आउट करायचं आहे. सो टू फाइंड दिस थिंग tm plus n, we will replace n by m plus n in the above formula. So tm plus n is equal to a plus, now n is replaced by m plus n minus 1 into d. Just replace m plus n by, just replace this n by m plus n, we will get this formula. So now if I observe equation number 1, we are having the value of a plus m minus n, m plus n minus 1 into d to be 0, and tm plus n, very similar side, a plus m plus n minus 1 into d. So from equation 1 we can have the replacement for tm plus n, this is equal to 0. So we can mention here from equation number 1. So this is what we want, that the m plus nth term of an arithmetic progression is 0. So this is very simple kind of example. Please note all the terms, all the answer of this question. Read, memorize and remember. Thanks for watching.